first of all, can anyone tell me what is the disadvantage of static routing? Why we come up with dynamic routing? Because interviewer can also ask you this question.
We can't use this for large networks.
Very
Many.
good. This is a very good reason. Implementation in large network will be complex.
Yeah.
It will be very complex. So static routing is good, suitable, because here in a static routing we don't need CPU, right? But in dynamic routing, router need to maintain the routing table. They need CPU because of routing protocol. Sometime we observe in real time that our router is hanging because of routing protocol using high CPU utilization. But in static routing, we don't have any protocol which is running on the router. Directly we are building the routing table of router manually. So that is the benefit of a static routing, but disadvantage is we cannot implement in large network, because let's say we have thousands of prefixes coming from somewhere to a router, and you need to install those prefixes, thousands prefixes. Is it possible to configure thousands time IP route command? No. So in large network, we cannot implement a static routing. It will be very complicated. So that's why we come up with dynamic routing. In dynamic routing, what we will do, we will run a process on router. And according to that process, router will share routing information. Done. Guys, router need how many information to build routing table? This is also a question. Router need how many information and what information to build the routing table?
Source IP and destination.
No. Source IP is not required to build the routing table.
Physically connected interface
No,
networks.
what I am asking you that to build the routing table, what information is required? In the routing table of router, what information you are looking there? Router need what? First of all, whenever router will get one undirectly connected network, any network which is not known by router. So router need exit interface to forward traffic to that network, which will be my exit interface. Yes or no?
Yes, sir.
So to build the
Yes,
routing
sir.
table, first thing which is required is the network, remote network, network ID, and subnet mask and exit interface. These three things are required to build the routing table. Yes or no?
Yes, sir. But in dynamic routing, sir, connected network only we were advertising, no, sir. In that.
No, I am not talking about the advertising, brother. I am
Okay.
talking about what information is required to build the routing table,
Okay.
right? So to build a routing table, router need network, remote network, subnet mask, and then next hop address,
Just
or you can say exit interface. If a router have exit interface, then also router can learn the network. If router have next hop IP address, then also router can learn a network. In a static routing, network engineer will provide these information to router. Exactly, in a static routing, we are providing this information to router by running command IP route. Yes or no?
yes.
Let's say on this router, I want to add one network in the routing table. So what I will do, I will run command IP route 10.1.1.0, subnet mask 255.255.255.0, and exit interface is F0/0. This is how I can add one entry. Yes or no here?
Yes, sir.
But in dynamic routing, router itself give information to their neighbor router. Let's say here we have X network. Here we have one network X. Here we have one network Y. Right? So this router, let's say this is R1 and this one is R2. R1 know how many network? X network. But R1 don't know about Y network. In the same way, R2 don't know about X network. Yes or no?
Yes, sir.
Yes.
So in dynamic routing, in a static routing, manually you will tell to router 1 that for Y network your exit interface will be F0/0. In dynamic routing, router 1 will share the information with router 2 to their neighbor. It will say that I have one network X. I have one network X network, and this is how router 2 will get to know about X network. In the same way, router 2 will forward to router 1. Router 2 will also forward which network? I
Why
have
not?
Y network. Y network. Right? So both router 1 and router 2 will get remote network. This is how a dynamic routing will work. Getting my point, guys? Yes or
Yes.
no? Same thing will happen. Okay, let's say when router 2 will receive X network information, how router 2 will came to know about the next hop IP address? What is my question? My question is, see here again I am explaining you the question. Here this is X network, this is Y network. Done. Router 1 have sent X network information to router 1. This is router 1, this is router 2 to router 2. How router 2 will came to know about the next hop IP address?
By knowing the X network advertisement interface, sir.
No, by knowing the source IP address. This network is coming from where? In this packet, source IP will be what? IP address of F0/0, yes or
Yes, zero,
no?
sir. Yes, sir, yes.
So this is how in the packet there will be source address, and through that source address router 2 can understand. Router 2 will came to know, okay, I am getting one network from, let's say, 12.1.1.1. That means whenever I need to forward some traffic to X network, I will forward traffic to this
Well,
source
not very well.
12.1.1.1. Yes or no?
Yes.
So always keep in mind, next hop will be learned by router with source IP address in the update message. This is very important term for the dynamic to understand the dynamic routing. Okay. Next thing, like here, drawback of static routing is it is very complex, to implement in large network, and we don't have redundancy. But this is wrong. We can achieve redundancy as well by manipulating the AD value. After that, types of dynamic routing. This is fine. Dynamic routing, till now we have discussed what, that in a static routing manually we configure the remote network, but in dynamic routing, router itself will advertise network. Let's say router 1 have X network and router 2 have Y network. Router 1 will tell about X network to router 2, router 2 will tell about Y network to router 1. Means all router will share their directly connected network with their neighbor, except the network which is running on that link where neighbor is connected. Means it will not include, let's say this router have multiple network, here 2L network, here Y network, here Z network. So router will send only Y and Z network information to router number 1, not 2L network. And let's say this router have one more neighbor here, R3. So when it will forward update message to R3, it will send how many network? Y network, Z network,
Z
and
network
2L
and
network also, right? But it will not include the network which is running on that link. Always keep in mind that this also.
But while advertising, we have to advertise with three, no, sir. Or also we have to advertise, right?
It will not advertise those network, oh sorry, that network which is running on that link where neighbor is connected. On the same segment, we can say, let's say R1 and R2. Whenever R1 will advertise any network to R2, it will not include the network which is running on this link. When
Okay.
router 2 will advertise to router 3, it will not include the network which is running on this link. But let's say here we have router 3 also, R3, and here is one network, X network. So router 1 will advertise X network to router 2. Router 2 will advertise how many network to router number 3?
Two, sir. 12 and X.
Yes, 12 and X.
Yes.
it will not include the network which is running on this link. Okay.
Sir, but while configuration, we have to enter, no, sir. What?
Configuration is different thing. We are not discussing configure. When we need to configure, actually we will enable routing protocol on the interface of router, not on the router,
Okay.
right? So with
Yes.
the help of network command, later we will discuss how to enable the routing protocol or how to advertise the network, how to advertise the interfaces. Those are the different things.
Okay.
I am talking about the behavior of dynamic routing. This
Okay.
will be fixed. This will be the same for all routing protocol. This is the
Okay.
concept of dynamic routing protocol, that when router advertise a prefix to their neighbor, it never include the network which is running on the same segment. This is the rule. Done.
Yes, sir.
And how router will learn next hop IP address with the help of source
So,
IP
sir.
address in the update. So only keep these two things in mind now. Done. After that, see types of dynamic routing protocol. We have some types of dynamic routing protocol. First is distance vector routing protocol. An example of distance vector routing protocol is RIP. Your RIP is an distance vector routing protocol. So now we are not discussing what is RIP. I am not going to discuss what is RIP routing protocol now. Just understand the behavior and the properties of distance vector routing protocol, right? First, we will understand the properties of distance vector routing protocol, then properties of link state routing protocol, then properties of advanced distance vector routing protocol and path vector routing protocol. Once we will understand the properties of these protocol, guys, easily we can understand all protocols like RIP, OSPF, EIGRP and BGP. Okay, directly we will
So
move
there
to the
is two version in
configuration.
RIP, sir.
Yes, we have
Both
two
are
versions.
distance vector.
Yes, both are distance vector.
And sir, what about the ISIS?
ISIS is link state routing protocol.
Okay, sir.
Link state. Okay. So that's why I'm telling you, if you will understand the properties of link state routing protocol, right, you can easily understand ISIS protocol. You can easily understand OSPF protocol, because both are link state routing protocol. If you will understand the properties of distance vector routing protocol, you can understand RIP version 1, RIP version 2. There are some difference only, so that you need to learn. Then EIGRP is also there and BGP is also there. Done. So let's begin from distance vector routing protocol. Guys, if I will talk about the distance vector routing protocol, let me discuss the first behavior of distance vector routing protocol. Distance means what? In networking, distance means hops.
Hopes.
Hops means your L3 device, or you can say
Routers.
router. So distance means hops and vector means direction, means next hop. Direction. So distance vector routing protocol is, you know, defining that I am a distance vector routing protocol. Means distance means hop count, means the, the main work of each routing protocol is selecting best path. For selecting best path, calculating metric. So distance vector routing protocol calculate their metric on the basis of hop count. Hop count, number of hop. By the way, this is not good, because see, understand one scenario over here. Let's say I have one router over here, one router over here, one router over here, and one router here, like this. See, let's say R1, R2, R2, R3 and R4. Here let's say we have the speed is 101 Mbps. Here we have a speed of 100 Mbps. Here we have a speed of 100 Mbps. Here we have a speed of 100 Mbps. Guys, between router 1 and router 2, how many paths are there?
2 paths.
2 paths. Which path is best according to you? Let's say here router 2 is connected with one network. Router 2 is connected with one network whose network ID is 192.168.10.0/24. Done. Now router 2 will advertise this network to router 1 also directly and to router 4 also. Because in dynamic routing, as I told you, that in dynamic routing, router will advertise the directly connected network with their neighbor. So router 1 will have 2 paths. One is via router number 2 and one is via this. So it will, router 1 means distance vector routing protocol will check what? The hop count. See, via this path, hop count is how many hop this network is away? Only one hop away. Yes or no?
Yes, sir.
And via this path, how many hop destination network is away? 1, 2, 3 hop
3.
away. So according to distance vector routing protocol, which path is best? Because hop is nothing but metric.
Sir, when counting the hop, it will count exit interface of router 2 or entry interface of router 1.
What you are saying? What is your question?
So when you are counting the hop, it will count exit interface of router 2 or entry
Next hop
interface
IP
of
address.
router 1.
Next hop, next IP, next hop. Next
Means
hop.
entry interface of R1.
Yes.
Okay.
Done. So this is the problem of distance vector routing protocol. That's why we are not using nowadays. Very few organizations are using in a small network, because we don't need good hardware to run distance vector routing protocol. That's why we are using still. So see, according to us, this path is best, right? Because here we have more bandwidth, but RIP don't have any algorithm to calculate metric on the basis of bandwidth of link. Always keep in mind. So RIP means distance vector routing protocol don't have capability to detect the link bandwidth, right? It's calculate metric on the basis of hop count. Yes. Is it clear? This is the first property of distance vector routing protocol. First property is what? It. Yes, guys. What is the first property of distance vector routing protocol?
It calculates the
Considered
metric on the basis
hop
of
count when counting, calculating the best path.
Yes. Hop count. Second properties of distance vector routing protocol is it always sends periodic update. You know what do you mean by this? Let me make you understand. Let's say I have two router, R1 and R2. Here IP address is let's say 12.1. Here IP address is let's say 12.2. And router 1 have one network. Let's say 10.1.1.0/24. So definitely router will send one update message. One message. It will send one message to router 2 to share which network? To share 10.1.1.0/24 network. It will share this network in the update message. So router 2 will do what? Router 2 will make one entry in their routing table. 10.1.1.0 is reachable via 12.1.1.1 because in the update there will be source, right? Done. Do you think router 1 again need to send same network information to R2? No. Yes or no? But all distance vector routing protocols share periodic update. It will share same information with same address after a periodic interval of time to router number 2. So it is using link bandwidth, unnecessary. It is using the bandwidth of link. Now question is why it is sending the periodic update, guys. Reason can be anything. Reason, one reason is distance vector routing protocol is not reliable protocol. So we don't have any acknowledgement over here. So when router 1 is advertising a network to router number 2, router 1 will not get acknowledgement that router 2 have received or not. That's why it is advertising again and again. It can be the logic. But distance vector routing protocol always send periodic update. Is it clear, guys? Two properties of distance vector routing protocol. Abhishek?
Yes, sir.
May I know the both properties? Yes, Abhishek.
Yes, I got it, sir.
Can you explain or not? First
I can't
property is
elaborate,
what?
but
First
I
property
understood.
is distance vector
Mat-
routing protocol calculate their metric on the basis
Matrix
of
on basis of hope count.
hop count. That is not good because router should use link
So
bandwidth to calculate the
bandwidth
metric.
also, yeah, on the bandwidth also shortlisted there.
Yes.
Yes.
And the second is it send the periodic update,
Yes.
which is not necessary, right? Router have sent. So reason is we don't have acknowledgement over here. Done. So
Yes.
we have discussed this two property. Distance means hop. Here I have written as well, guys, everything. Like that means metric. Okay. Now in distance vector routing protocol, we have some loop avoidance mechanism. Like we have a split horizon, we have route poisoning. So we will understand both, right? Okay, let me discuss now split horizon. Let's say in distance vector routing protocol, we have router 1 over here, R1, R2. Here IP is let's say 12.1. Here IP is 12.2. Router 1 have one network, let's say X. So router 1 will advertise X network with router 2. Yes. Now router 2 have received one network. Definitely it will advertise that network to their neighbor. So router 2 will also send that network information with R1. Yes or no?
Yes, sir.
And this is what? This is loop, guys, because router 1 have advertised network X and it is receiving same network information from their neighbor. So this is what? Loop. So in distance vector routing protocol, we have one rule. we have one rule. Rule is never advertise the prefix from that interface. No, sorry. Never advertise those prefix from that interface which you have received from, which you have learned on same interface. Means router 2 is learning X network information on this interface, so it will not advertise same network from same interface, from the receiving interface, you can say. So this is rule. Do not send the network information which you have received on an interface from that interface, or from that interface do not send the same network information. You can read the rule. You can type in the Google the split horizon. What is a split horizon? Let me show you. What is See, a split horizon is a method used by distance vector routing protocol to prevent routing loop. The basic principle is simple. Never send routing information back in the direction from which it was received. Right? Never send routing information back in the direction from which it was received. This is the principle of split horizon, and all distance vector routing protocols support split horizon, and by default on Cisco devices this feature is enabled. So router 2 will never send X network information from this interface, right? So loop will not form. Is it clear?
Yes, sir.
Now I have router 1, router 2 and router 3. Now again router 1 have one network X network. So router 1 will advertise to router 2 to router 3. Router 2 will also advertise to router 3, and router 3 will also advertise to router 2. Yes or no? Guys, tell me, when router 3 will advertise X network information to router 2, will router 2 accept? What I am saying, that when
No, sir.
no, why?
Sir, there is a rule, right, sir? We cannot share neighbor information.
No, not rule is there. See, when R1 is sending update to R2, number
Yes,
of
sir.
hop count is 1.
One.
When R2 will share to R3, hop count will be what? 2. So router 3 is receiving X network information from router 2 with what hop count? 2.
Oh, no.
And
Yes,
it
sir.
is receiving same network information from router number 1 with what
One.
hop count? 1.
One.
So it will not accept it, because it
Okay.
has already same network information with lower metric.
Okay.
Done. So it will
Yeah.
not accept.
Yes, sir.
Now after some time, if this link will goes down, guys, then what will happen?
It will accept, sir.
No, sir.
Then it will definitely accept.
Yes,
Or
because our
let's say this link will goes down. If this link will goes down, then what will happen? How router 2 will learn?
Via router 3, sir.
Via R3. So it is actually, it is advertising, it is sending the periodic update. Right, it is sending the periodic update. So after some time, after periodic interval of time, router 3 will learn the alternate path if this path will goes down. Let's say this link will goes down. So it has one network on this interface, let's say 0/0 interface. First of all, it will flush this entry. It will remove X network information from the routing table, and then it is going to ask to router 2 that do you have reachability from X network? See, now router 3 is receiving same network information on this interface also and sending same network information from this interface. How it is possible? Because here we have a split horizon, right? So no guys, this is not the split horizon. In this update, when router 3 will send update to router 2, metric will mark as infinity. Infinity. It will send the X network information with metric what? Infinity. Infinity metric means from me there is no reachability. There is no delay is infinity means prefix is not reachable. Done. And whenever a router send the same prefix which router is receiving on that interface is nothing but route poisoning. Done. So this time here when router will send update message with delay infinity, that is route poisoning. This is not the breaking of rule. Here I have already mentioned everything what is a split horizon and route poisoning. Like you can see the topology. R3 is receiving the information of network A. A network is running on router number 1 from two side, but router 3 will store via router number 1 definitely because it have received the lower metric. But if R3 will lose the connectivity to via R1, then R3 will send update to R2 and mark metric as infinity. This is not breaking the rule of split horizon. It's working fine and that's called route poisoning. Is it clear now? Hello guys. Tell me guys, clear or not?
Yes, sir.
Yes, sir.
Okay. So these are the property of distance vector routing protocol. Done. An example of distance vector routing protocol is RIP. Okay. So in RIP also you will see the periodic update. Whatever properties we had discussed, the best path selection, metric calculation, these things will be same. Done. Can I move to link state routing protocol now? Yes guys.
Yes, sir. Yes, sir.
Okay, sir.
Okay. So first properties of link state routing protocol is, always keep in mind, it maintains 3 types of table. Very intelligent protocol. See, if a routing protocol is using the multiple table, so there is advantage as well and disadvantage as well. Advantage is definitely it will be very easy while troubleshooting. We can check the database, neighbor table, routing table, right? Everything is separate there. But it is using the CPU utilization as well. Other hand. Okay, so link state routing protocol maintains 3 types of table: neighbor table, database table, and routing table. When you will configure the link state routing protocol on 2 router, let's say here you have configured the link state routing protocol. So first both router will become neighbor. It will maintain one separate table for it. In neighbor table both will make one entry. 2 1 12.2. Router 1 will say my neighbor is 12.1.1.2 and router 1 will also make a one entry in the neighbor table. The neighbor is 12.1.1.1 like this. All link state routing protocol. After that it will exchange the routing table, and after exchanging routing table it will maintain what? Link state routing protocol, never exchange the routing table first of all. Most of the people are saying link state routing protocol exchange the routing table. Link state routing protocol exchange the database, right? Both will exchange their database. We will understand how OSPF or routing protocol, link state routing protocol will build the database or routing table. These things are, we will understand in the upcoming day. Just I am making you understand the properties of link state routing protocol. It will maintain one neighbor table, then it will maintain one database table. In their database table, there will be database of their own as well, on router database as well, and the database of neighbor, or maybe database of all router in the OSPF domain or link state routing protocol domain. And after building the database, routers build what routing table. In the routing table, it will install the best path from the database. On the database, it will run one algorithm, and after running the algorithm, it will calculate the routing table. In case of distance vector routing protocol, information was directly exchanged between router, but in case of link state routing protocol, router will not directly share the information. First of all, router will check some parameter, then router will become neighbor. After becoming the neighbor, router will exchange the database, means the network information, and after exchanging the database, router will build routing table. And here we have periodic update as well as trigger update. In link state routing protocol, we have periodic update as well as trigger update. So link state routing protocol support periodic update as well as trigger update. Trigger update means what? Whenever change will occur. And periodic means after a specific interval of time. Trigger update means when there is a change in topology, router will send trigger update. Okay. And here we have some periodic update as well. Then metric is depends on the link property. It is clear with the name link state routing protocol. So in distance vector routing protocol, metric depends on the hop count on the hop, but here metric depends on the link property. Routing is not done by rumors. In distance vector routing protocol, there is no database, so all routers are depend on their neighbor. So that is routing by rumors as well, because router never knows about the actual originator, that who is originating the network. All routers are depend to their neighbor. That is routing by rumors. But in case of link state routing protocol, a router will have view of entire topology. A router can design the entire topology by checking their database. Very powerful routing protocol. Yes or no?
Yes, sir.
Here we don't have any hop limit, but in distance vector routing protocol we have some hop limit as well. Then if I will talk about the update, so guys, there are 4 types of update: periodic, trigger. And periodic can be full and it can be partial, and trigger can be also partial and full. Partial means only changed information, and full means the complete information. Let's say a router have 10 number of prefixes and you have add one new network there, so total number of network on that router is 11, right? So full update means it will include the all 11 network in the update message, and partial update means it will include only the new network in the update message. So that is partial, only changed information. Got it? Is it clear?
Yes, sir.
Now distance vector routing protocol always send full update, but link state routing protocol send both full as well as partial. Okay, an example of link state routing protocol is OSPF. Now guys, we have one more routing protocol, that is advanced distance vector routing protocol. So advanced distance vector routing protocol is nothing but combination of distance vector routing protocol and link state routing protocol. It has advanced distance vector routing protocol have some good properties of distance vector protocol and some good properties of link state routing protocol. It is combination of both. Like advanced distance vector routing protocol has some properties of distance vector as well as link state routing protocol. Advanced distance vector routing protocol maintain three types of table. This is properties of link state routing protocol. Yes or no?
Yes, sir.
After that, it consider hop count as well. So this is the property of distance vector routing
Distance
protocol.
vector.
So this behavior is like link state routing protocol, means it calculate metric on the basis of link property. So this is like link state routing protocol. Okay. So advanced distance vector routing protocol is EIGRP, guys. While discussing EIGRP, you will understand all the concept of advanced distance, but for now just understand it have some property of distance vector, some property of link state. Like it maintain three types of table. This is property of link state routing protocol. It also consider the hop count. This is the property of distance vector routing protocol. It calculate metric on the basis of link property. This is the property of
Link
link
state.
state routing protocol. Okay, that's it. Now my first routing protocol is RIP. Okay, this is distance vector routing protocol. So RIP stands for routing information protocol. It is an distance vector routing protocol. It work at layer 7. AD value is 120. It uses UDP port number what? RIP is using what port number? Hello. Rohit. What is the port number of RIP?
Sir, 520.
Okay. Routing information protocol is a distance vector routing protocol which use hop count as a metric. Okay, we already discussed this. The largest number of hop allowed for RIP is 15,
15.
which limit the size of network that RIP can support. Yes or no? Then RIP implemented the split horizon route poisoning and hold on time mechanism to prevent incorrect routing information being propagated in RIP version 1 router broadcast update. Guys, there is one very good question. See, very general question. Like RIP version 1, we had sent update message on the broadcast message. In RIP version 2, we had shifted the address to multicast. And in many cases, we observe that we are shifting from broadcast to multicast. Like in IPv6, we don't have any term like broadcast. So may I know what is the reason, what is the benefit of shifting on multicast from broadcast? Can anyone tell me the logical reason? What can be the benefit of shifting on multicast from broadcast?
Flooding can be decreased.
Flooding,
Broadcast
how?
consume more memory, sir.
How?
In broadcast, it's broadcast the packets to all the routers.
Okay.
In multicast, it's only to some particular devices it will advertise the packet.
Exactly. Like, let's say I have one router, this one R1, and R1 have received one, let's say, message. Okay. And this is a message, let's say it is a message of telnet. telnet at application layer. At transport layer, source port number will be what, guys? Source port will be the random port number, and destination port will be what?
23, sir.
23. After that, source IP, let's say 10.1.1.1. It is coming from 10.1.1.1. Destination IP is, let's say, 8.8.8.8. Anything. And in protocol field, value will be TCP protocol number. After that, at layer 2, source MAC, let's say 0A, and destination MAC is broadcast.
FF.
Now, router will accept the traffic at layer 2. Yes or no? Because it is broadcast, it can be for router 1 also. It will check the type field. It will identify the upper layer protocol and it will hand over to upper layer protocol. Yes or no? Here destination is what? Broadcast. Let's say at layer 2, this is not 8.8.8.8. Destination is, this is not the telnet traffic. This is, let's say, traffic of RIP or RIP protocol. Destination is 255.255.255.255. Destination IP address is what? Broadcast. And destination MAC address is what? Broadcast. So this router will process this traffic at layer 2 also and at layer 3 also. Yes or no? Yes or no? Because destination is broadcast. But if destination is what? Multicast. Let's say 224.1.1.1, 0.0.1. This is the multicast address. So here destination MAC will be also what, guys? Multicast address. So first router will check that, okay, is my interface member of this multicast group? If yes, then only I will accept it, otherwise I will drop it. So it will, if RIP is not running on router number 1, then it can drop the traffic at layer 2 if destination is multicast. If destination is broadcast, if RIP is not running on router 1, then also it have to process the traffic till network layer. Till not network layer, in fact till transport layer. At transport layer, it will check the destination port. Destination port, oh my god, this service is not available over here, so it will drop. Yes or no, guys? So this is the benefit to reduce the CPU utilization of devices. We are shifting from broadcast to multicast. So in RIP version 1, we were sending update on broadcast address. After every 30 seconds, this is the timer, update timer. RIP always send update message after every 30 seconds. Then here also you can see the timer. We have multiple timer in RIP routing protocol, like update timer. Update timer means sending the update message to the neighbor is 30 seconds. Then invalid time is 180 seconds. Then flush time. Then hold on time. Hold on time is 180 seconds. That's what do you mean by this timer? Let's say here I have one router R1, and this router, let's say we have one more router here. Here we have one X network behind router number 1 is 10.1.1.0/24. Okay, let's say this is the LAN network of router. So what router 1 and both router I am running RIP. IP address of this interface is nothing but 12.1 and here IP address is nothing but 12.2. Right? I am running RIP routing protocol on both router. So router 1 will encapsulate one update message. It will encapsulate one update message. In update message, it will include which network? 10.1.1. Let me write it here. 10.1.1.0/24. This will be the information in update message. After that, it will hand over to lower layer, transport layer. Transport layer will add source port number, destination port number, then it will hand over to network layer. At network layer, it will add IP header. In IP header, source IP will be 12.1.1.1, the IP address of exit interface from where this router is sending the update message. And destination will depends on the protocol. In all routing protocol, source will be always the IP address of exit interface and destination will be depend on the protocol, the which protocols you are running. If you are running RIP version 1, then destination will be 255.255.255 broadcast. Okay. So router 1 will send one update message to router 2. In the update message, there will be this network information. Now router 2 have learn one network 10.1.1.0/24. It will start one timer for this network here, right? 30 seconds. Means after 30 seconds, it will receive one more network. Let's say timer is starting from 1, then 2 seconds, 3 seconds, then 4 seconds, 5 seconds, and after 30 seconds it will receive another update message. After 30 seconds it will receive another update message. Again timer will reset to 0 second. Once it will receive the update message, this timer will reset to 0 second. Guys, let's say because of congestion on the link, router 2 have not received one update message. Then it will receive the update message after how much time? After 60 seconds, second update message, right? But flush time is what? Here you can see the flush time is 240 seconds. So it will not flush the network information if it will miss one update message, if it will miss 2 update message, if it will miss 3 update message. Yes or no? After missing how many update message, router 2 will discard this update message, guys? Flush time is 240 second. 240 second. 240 second means how many minutes?
4 minutes.
For 4 minutes, right? So if it will not receive any update message till 180 second, then it will declare this prefix as invalid. Means it will not use this prefix. If it will receive a traffic for this destination, it will drop the traffic. Router will drop the traffic. And after 180 second, it will wait, but for this time this prefix is invalid, but still it is waiting for 240 second. After 240 second, it will flush it from the table. It will flush it from the table. So this is the disadvantage of RIP, guys. Means let's say R1, from R1 we have removed this network. We have removed this network from R1. So router 2 will flush this network information from their routing table after
240 seconds.
240 seconds. Okay. So this is how this timer works. After that, these are the command to enable RIP protocol. Okay. Then we have compare between RIP version 1 and RIP version 2. Before this, what I am going to do, I am going to make you understand the packet flow of RIP first. Let's understand the packet flow. not packet tracer, GNS3. One minute, guys. NoShut IP address 12.1.1.1 255.255.255.0 exit interface f1/0 NoShut and IP address is 192.168.10. Let's say 10 255.255.255.0. I've configured the IP address on router 1. So IP interface brief exclude unassigned. Done. Now let me take you to PC2, sorry, router 2. Interface f0/0. I'm just configuring the IP address 192.168.20.10 255.255.255.0. Right now, see, do so IP route. In the routing table of router, there is directly connected network. There is no any information on router number 2. There is no any information about 192.168.10.0 network. In the same way, on router number 1, so IP route, only directly connected prefixes are there. Now to exchange routing information between R1 and R2, I am going to configure RIP routing protocol here. Command to configure RIP is router RIP. First of all, this command, guys, after running this command on router, actually router will allocate some memory to RIP for the RIP, right? We are not running this command to enable RIP. This command will allocate some memory to RIP protocol over here. After that, as I told you that we enable routing protocol on the interface of router. So what we will do, through network command we will enable the RIP routing protocol on the interface of router. Let's say here I am running network 12.1.1.0. Once I will hit enter, this router R1 will check that this network is running on which interface. So it will find F0/0. It will enable RIP protocol on this interface. Okay. See, I am going to capture this link before running this command. Let me capture. And R1. See, once I will run this command, router will check what? This network is running on which interface, and this network is running on F0/0, so it will enable RIP on 0/0 interface, and it will start sending the update message from the RIP enable interface. Once you will enable RIP routing protocol on an interface, that interface will start sending the update message. So see, I have enabled it and it have sent one request message, you can see. If you will open this request message, see guys. In the open message, source IP address is what? 12.1.1.1 means exit interface IP address. Destination IP address is what? 255.255.255.255. Source port is 520, destination port is 520. And this is the message of RIP, routing information protocol. And if you will open this in this message in detail, so see here, address not found. We don't have any address in the update message. So this is not the actual update message, guys. Done. After that, it is not sending any message. After 30 seconds, it will send one same message again. Got it? And on router, if you want to verify the routing protocol, you can run command show IP protocol. By running command show IP protocol, you can see here I have run the command show IP protocol. After that, routing protocol is RIP. Routing protocol is RIP. Then we have some information about filtering. We will discuss about this later. See, outgoing update filter list for all interfaces not set. Incoming update filter list for all interfaces not set. We will discuss about the filtering, but here you are able to see that we don't have any filtering on any interface. After that, sending update message after every 30 seconds, and next due is 6 seconds. Means after 6 seconds I am going to send the next update message. Invalid after 180 seconds, hold on time is 180 seconds, and flush time is 240 seconds. Done. The default version control, send message of VTP version 1, receive any version. See, I have not defined any version in RIP, right? So this is default version, guys. After that, automatic network summarization is in effect, so we will discuss about these things later. After that, maximum path that can support is 4, and we are performing routing for 12.0.0.0. because RIP is a class full network. We will understand this also in upcoming day, so that's why it have make entry like this, that 12.0.0, but I have defined 12.1.1.1. it will consider as class full. Done, guys. And here you can see the distance, means AD value is 120. So this is how I enable RIP routing protocol and on fast Ethernet 0/0. Now we need to enable RIP routing protocol on F1/0 or not, guys? Tell me, do we need to advertise or enable RIP routing protocol on F1/0? Yes, if you will not advertise F1/0 in RIP, so R1 will not include this network in the update message. So R2 will never learn this network. So I need to advertise this also, this interface also, router RIP, and this time I am going to define the version as well, version 1, and then network 192.168.10.0. It will look this network is running on which interface. Okay, this one is running on F1/0. Let me enable RIP. Done. And so IP protocol, by running this command you can see over here routing for 2 network now. Done. And now I am going to enable RIP on router number 2. Router RIP version 1 network 12.1.1.0 and network 192.168.20.0. Through network command I have enabled RIP on both interface, and see the capturing over here. Routers are getting the response message. Now it is sending, see this message. Who is sending this message? 12.2 means router 2. And why router 2 is sending this message? To share the network information. Which network information? 192.168.20.1. And what is the metric in update? 1. See, router 2 is sending this network information with metric what? 1. Source port, destination port, you can see source IP, destination IP. When router 1 is sending the update message, where is, here is the update message of router 1. So router 1 is sending with this network 192.168.10.0. It is not including the network on common segment, that is 2L. Okay, and these routers will send this update periodically after every 30 seconds. And now if you want to verify the routing table of router, you can see so IP route. In the routing table there is one entry. This router have learned this network from RIP. So R4 RIP over here. Network is 192.168.20.0/24. AD value is 120 and next hop IP address is 12.1.1.2. It have learned just 27 seconds ago. On which interface? On fast Ethernet 0/0. So it have stored this network information in the routing table. Done. Very good. Router 2. So IP route. Router 2 have also learned one network through RIP, that is 192.168.10.0. AD value is 120, metric is 1, and next hop IP address is 12.1.1.1. 20 seconds ago and on this interface. Done. Now if you want to verify the connectivity, definitely it will work. Ping 192.168.20.10 and source is 192.168.10.10. See, it's working. Ping will work. Everything is working fine. Okay, so when we are enabling the RIP on router number 1, what router 1 did? It generate one update message. In the update message it include which network? 192.168.10.0 network. Then it will hand over to lower layer, right? 520 will be the source port and 520 will be the destination port. Oh, he is joining now. Destination port. Source IP will be 12.1.1.1 and destination IP will be 255.255.255.255. Source MAC will be the MAC address of exit interface and destination MAC will be broadcast. Right? And this is how router 2 will also generate the update message, where it will include which network information? 20.0. Source IP will be 12.2. Destination will be broadcast. Yes. and here also you are able to see this information. And this is how both router have built their routing table. So IP route, and if you want to filter the routing table, so you can filter by running command like this. Let me show me those prefix only which you have learned through RIP. 192.168.20.0/24 via 12.1.1.2. Is it clear to everyone?
Yes, sir.
Now what I am going to do, on this router I am going to create some loopback. Loopback is, you can consider your loopback as LAN network. Let's say here loopback 1 is equal to 10.1.1.1, loopback 2 is equal to 10.1.2.1. Let me copy it and let me paste it over here. Let's say correct it. Loopback 3, loopback 4, here IP address is 3, here IP address is 4 with /24 /24 /24 /24 /24. And on router 2 also I am going to advertise some network. Here we have 5, 6, 7, 8. Okay. Now suppose these are my LAN network. These are my LAN network on router number 2. I am going to add this loopback, guys. See, actually I want to make you understand the summarization. What is why summarize, what is the, why router is considering 12.0.0.0 when I am advertising network 12.1.1.1. Interface loopback 1, IP address 10.1.1.1 255.255.255.0. Interface loopback 2, IP address is 10.1.2.1. okay. 3, loopback 4, done. Now I am going to advertise it in RIP. Router RIP network 10.1.0.0. done. See, so IP protocol, it has considered it 10.0.0.0. When I will advertise this network on router number 2, it will also consider it as 10.0.0.0. So tell me, can this LAN user communicate with this LAN user? Interface loopback 1, IP address is 10.1.5.1 255.255.255.0. Interface loopback 2, IP address is 6 over here, loopback 3, 7 over here, loopback 4, 8 over here. Router RIP network 10.1.0.0. Guys, ping 10.1.5.1, source 10.1.1.1. will it work? Will it work, guys, or not? Yes, Rohit, tell me.
Yes, sir, it will work.
It will not work. Can anyone explain how it's work? What will happen?
When we
Router will
will,
check the routing table.
yeah, when we will define the R2 loopback and R1 loopback, vice versa.
It should work or not.
I think not,
Why?
because we have not defined the R2 loopback in R1 and uh, R1 loopback into R2.
No, I cannot define the R2 loop back to R1. Na? It will advertise by RIP.
Yeah,
I have advertised all loopback interface in RIP routing protocol. Here you can see now. So IP protocol. This network is running, and so IP interface brief. These are the loopback. But it will not work. You know why? Because so IP route. In the routing table, you can see of this router, there is there any network as 10.1.5.0? No. Because through RIP, it have not learned any 10 prefixes. Why? Because R2 is advertising which network? It is advertising 10.0.0.0. And router 1 have already this network and that is directly connected. So why it will accept from R2?
okay.
Okay guys, actually what is happening, by default auto summarization is enabled. Router RIP and no auto summary. After running this command, see by default on router number 2, this command is enabled. So IP protocol. Here you can see automatic network summarization is in effect. Yes or no? So automatic summarization means it is performing summarization automatically. And here I have run command what? No auto summary, and so IP protocol. Still you can see. So always keep in mind RIP version 1 does not support classless routing. It is advertising 10.0.0.0 still. So this is the difference between version 1 and version 2. We have multiple, like one difference is here we have destination is broadcast, here we have multicast in version 2. It is class full routing protocol and it is classless routing protocol. So class full means we cannot use classless network. Here we have classless network. Yes or no?
Yes, yes.
So here we will use which version? Version 2.
One.
Let me define version 2 over here. Router RIP version 2. So IP protocol version is version 2. Router RIP version 2. And when we are defining the RIP version 2, so IP protocol, here you can see the change in output. Auto summarization is in effect, so we will disable this also. It can send the update message to version 2 and it can receive the update message from the version 2 only. Means version 1 and version 2 is not compatible with each other. You cannot configure version 1 on R1 and version 2 on R2. After that, how many message it have send and receive. These are the information. Auto summarization is enabled, so let me disable the auto summarization. Say router RIP and no auto summary. Now it is not in effect, and so IP route RIP. Now you can see this router is receiving all individual prefixes. Yes or no?
Yes, yes.
In the same way, now router 1 is also receiving all individual prefixes. So IP route rip, you can see. Yes. So now we can ping 10.1.1.5.1, 5.1, and source is 10.1.1.1. Now it will work. You can see. Okay. So this is the second difference between the version 1 and the version 2. So we are actually not using the version 1. Somewhere we are using the RIP, so we and then also we are using version 2 only. Version 2 or default version. Then we have some more support here. We cannot, VLSM is not supported, VLSM is supported. MD5 authentication is also not supported by version 1, but version 2 can support MD5 authentication. Done. Done. Till here, is it clear?
Yes, sir.
Now we have some drawback of RIP as well. Like we have hop limit, metric. As you know, metric, it calculating metric on the basis of hop count. But it should check the link properties as well. Slow topology convergence, periodic update after 30 seconds, which increase the network traffic, and routing by rumors. These are the disadvantages of RIP. Now guys, let me check here. So IP protocol. See, in all routing protocol, first of all, you should be able to read the output of so IP protocol command first. In all dynamic routing protocol, in OSPF, EIGRP, or any other routing protocol, BGP, first you should be able to read this information. Okay. Like it is sending update. Okay, so these terms is clear to you. It can send the update message to version 2, receive the version 2, how many messages it have sent, how many messages it have received on fast ethernet 0/0, on fast ethernet 1/0, after that on loopback interface. Guys, tell me why this router is sending update message from the loopback interface. Should router 1 send update message from the loopback interface? Because loopback are the LAN interface, or this interface, this is your LAN interface. On this interface also router is sending the update message by default, but here update message is not required, right? So what we can do, what is the solution? Solution is very simple. We can tell to RIP protocol that RIP, please do not send any message from fast ethernet 1/0 and loopback 1 to loopback 4. Router RIP and say passive interface. Passive interface fast ethernet 1/0. Once we will configure one interface as passive interface, it will stop sending the update message. Okay. Passive interface loopback 1, loopback 2, loopback 3, loopback 4. How to verify it? By running command same show IP protocol. Passive interface fast ethernet 1/0, loopback 1 2 3 4, right? In the same way we will configure passive interface on R2 as well, because now if you want to see that router is forwarding update message from loopback interface or not, so you can enable debugging. Debug IP RIP events. Wait, see, it is sending the update message from loopback 1 interface fast Ethernet 0/0, loop back, maximize it, and see it is sending update from loop back 3, loop back 4, right? It is sending update message from all loopback interface from F1/0 also, but it should send hello message or update message from F0/0 only. Un all and config T, here router RIP passive interface F1/0 passive interface loopback 1, loopback 2, loopback 3, and loopback 4. What happened? Passive interface router RIP passive interface F1/0 interface loopback 1, loopback 2, loopback 3, and loopback 4. So I have configured the LAN interface as passive interface. Now it will not send the update message from LAN interface. Done. After that, you already know how to enable and disable auto summarization. Auto summarization means automatic summarization in class full, right? Router will summarize automatically. Guys, after that, it can support, RIP can support max to max 4 path in the routing table. Suppose for a single network, it can learn 4 different path, and we are performing routing for this network. After that, we have passive interface, then distance value. Done. Okay, now I'm going to close it. And see, in this topology, we have some network on router number 4, right? And I will advertise this network on router number 4. So router 4 will advertise it to router 2, router 3, and both router will advertise to router number 1. So router will perform what? 440 network. It will perform load balancing, because you will see that from both sides you can see the prefix is longitude prefix is same, then AD value will be same, and metric. Metric from router 2 is also what? 1, and metric from router 3 is also what? 1, 2. From both sides is 2. So metric is also same. So if all these 3 things is same, then router perform load balancing. So router will install both path in their routing table. Router 3 will install this path via router number 4 directly. Router 2 will also install via router number 4 directly. And if the primary link will goes down, then definitely it will store via secondary link. So it will be receiving the update message on alternate interface as well, but it will discarding. Okay, so tomorrow we will configure this network, and in this network we will configure RIP. We will discuss some more concept over here, and then we will move to some filtering part, or directly we will start EIGRP. We will start filtering in EIGRP. Okay.